Okay, we continue. So we are start for convert image to grayscale and perform normalization. So we have age and right and pair number some age train to the we have AC three axes type dimension two okay and we should run this one but not define. Okay, so it's how we need to run it from the beginning. Back. Then this one back. 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 So normalize will be okay here. Back. Back. Okay. Chain line shaft. Yes. Okay, so we have one dimension. Then right down. And chain right. Like this and then okay. We will have some. Okay. Check. Hi. No. We have some like this. Okay.
Normalized. So now pretty straightforward. What I ask you guys to do is to simply copy that cell, or copy that line, and we're gonna call that valid. The same as well here for.
Okay. We will copy them to my A3. Okay. Here we will have valley. And then here we have that. And we need to modify here also. Valley. Test. Okay. And then equal name and then it's finished. And this one we should trim. So okay. Trend. And here we should have value. Trend. Value. And here we have that. Okay. Then we have that. Okay. We run it again. Nothing wrong. And then we can take this one. And then take one. Right. So we have right. Official image strand. of figure showing my x-ray. Ray x-ray now please. Okay, right. So we sort it and we will have something like this. And we will have right and then mesh and the last one we will have something right now.
For X test thing, and so basically X valid is not here. So here we call it normalized image, our original image, and our grayscaled normalized images, and feed them to our network. And that's what we're going to be doing in the next step. So that's all what
next step. Let's see.
Hello everyone, and welcome to this exciting task. In task 5, we are going to understand the theory and intuition behind convolutional neural networks. So going to be tons of fun. So let's get started. So basically, this is the overview of convolutional neural networks. So the base of the convolutional neural network is simply here is a dense, fully connected artificial neural network. When we say dense or fully connected, that means that we have here a bunch of inputs, we have a bunch of hidden layers, and then we have the output. And when we say dense, that means that each of these neurons in one layer is fully connected to all the neurons in the subsequent layer, okay? And simply here, all these values in here, these indicates the weights, and that's basically what we do when we try to train these artificial neural networks. So a convolutional neural network performs some processes beforehand, before we feed the data to our dense, fully connected artificial neural network. So first, as I mentioned, is that the entire network, end to end, takes the images as an input and generates the label or target label as an output. So first, as you guys can see here, we have our image. What we do first is that we perform feature extraction. So we apply what we call it convolutions to simply extract features out of the image. Okay, so here we can have multiple feature detectors, and these feature detectors will be able to extract features. And once we do that, we will be able to, afterwards, to do what we call it pooling. And within the pooling is simply a step in which we compress the feature maps. We just wanted to reduce the size of the feature maps, let's say from 25 pixels by 25 pixels to maybe make them 12 by 12. And that's what we call it down sampling or pooling. And as you guys can see, the size here is much, much smaller compared to this one. And then after we do that, then we take all these pixels and then we flatten them up. We make them in just one single array, and then we feed them as an input to my dense, fully connected artificial neural network. So basically, we feed in here as image, we do convolutions, and then we down sample them or pool them, and then we take the pixels, we flatten them up, we're good to go, we feed that data to my dense, fully connected artificial neural network. An important point here is that after the convolutions, we generally apply a ReLU activation function. And ReLU stands for rectified linear unit. It sounds, fancy, but it's actually very, very simple. So as you guys can see here we have simply any value that is less than 0, that is negative, will be set to 0. And any value that is positive will be passed along. Basically, we're just going to pass it. Think of it as any number that is negative, we're just going to set it to 0, and that's it. So the advantage of applying ReLU in the hidden layers is that we generally improve the sparsity of the feature maps. And that's actually dramatically improved or enhanced the performance of the network. All right, okay. So that's simply our convolutional neural network. I just wanted to discuss as well a technique, and that's what we call it dropout technique. And a dropout technique is a regularization technique that is used for reducing overfitting in artificial neural networks. Simply put, this is our fully connected artificial neural network. What we do as the network trains is we just go pick up some of these neurons and then drop them out. Maybe we'll go and say, I need to get rid of 20% of all these neurons randomly. And actually, when we do that, surprisingly, you will find that the network performance improved dramatically. It's an amazing technique. And again, it's a regularization technique that is used to reduce overfitting in artificial neural networks. What happens is that when we train these neurons starts to develop codependency among each other during training. So when we actually drop out some of these neurons, you think of it as, like you basically like push the network down to the floor in a way, okay? And then it comes back much, much stronger. And that's what dropout basically does. And it performs amazing. It actually dramatically improves the performance of the networks. All right, so let's go ahead and follow this link in here. So this link in here. this is, again, I have this basically link open, and it's an amazing basically website that can show you how to visualize convolutional neural network in action. So here, this network is trained to classify different digits between 0 and 9. And as you guys can see, here we have our input layer. So that's my input layer. We can actually show it, and we can actually hide it here. And this is what we call the convolution layer 1, which is convolution layer 1. We can show it again, and then we can hide it. And then we have the downsampling layer, which is this one here. We can actually, again, show it. We can hide it. And again, as you guys can see, the size here is reduced. And because this network is a deep convolutional neural network, you will find that you have another convolution layer. We call it convolution layer 2, which is this one, followed by another downsampling. And then we flatten them up. As you guys can see here, this is the flattening. We add a hidden layer, and then here we have the output, which is simply just one of these neurons' outputs will fire, indicating the correct class. So let's go ahead and give it a shot. So what I can do here is I can go ahead and actually draw, let's say, number 5 in here, for example. So you can actually go ahead and draw number 5. So that's number 5, and see what's going to happen. Okay. So as you guys can see, the network actually, because it's not very complete. So actually, let's actually draw it much better. So let's actually draw, let's get number 5. That was a bad one. So here we go. So that's number 5. So as you guys can see here, the first guess of the network is actually 5, which is great. And in the output here, the neuron number 5 actually fired. They're lit up here. And it's amazing, this website basically shows you all the different visualization of different layers. So this is the first layer, which is the convolution layer 1. As you guys can see, these are the different variations of the image or the different feature maps. And afterwards, we downsample them. So we actually preserve pretty much the same features. And then afterwards here, we perform another convolutions, followed by another downsampling. We flatten it up. Again, we add another hidden layers here. And then here we feed it to the output. Again, pretty amazing. And as you guys can see here, the first guess is 5, and the second guess here is 3. So what I want you guys to do is please go ahead, pause the video, and I want you to pick maybe another number, and you can simply clear it up, write the number here, and see if the network works or not. So please go ahead, pause the video, and I will see you guys after the challenge.
Okay.
All right.
We can state that we do like this, and this one. What the hell? Okay, so how can we? I think we make something. I make something wrong. Oh shit. Okay, what is it? Again, we lost. Okay.
You guys were able to figure out the challenge. Maybe go ahead and maybe write number 3, for example, here. So that's number 3. Okay. Again, here 3. All right. And let's see what's going to happen. As you guys can see here, the first guess is 3, and the second guess is 7. And that's all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we are going to go ahead and actually build our convolutional neural network using Keras. And that's all what I have. Please stay tuned, and I will see you guys in the next lecture.
Okay, we're going to do it.
Hello, everyone, and welcome to this lecture. In this task, we are going to build our deep convolutional neural network from scratch. All right, so let's get started. So first, we are going to import our data set. We're going to import layers, and we're going to import models. So let's see how can we build our network. So what we're going to do here is that we're going to use Keras API to build our model, and we're going to use TensorFlow as a back end, basically. And what's amazing about Keras is that they made it extremely easy to build a CNN, extremely complex one with just a bunch of lines of code. So first, we are going to say, okay, my model is called CNN equals 2, and we're going to call it models.sequential. And basically, that's what we're going to do here. Is we're going to build our model in a sequential fashion. So that's what we're going to be doing here. So we're going to do sequential. So we're going to call that. That will be the first step. And then afterwards, think of it as we are building basically a Lego. So we are going to build the first layer, which is our convolution layer, and then another pooling layer, and then another convolution, another pooling, and then flatten it up, fully connected, and then dense basically layer, and that's it. That would be our CNN. So we're going to say, okay, CNN, let's take our model and add to it. So we're going to say .add, and then we are going to say, okay, go to my layers dot conv 2D, and then here we're going to specify basically how many convolutions do we need. So here, for example, I'm going to say I need 6 convolutions, and I need to specify the size as well of it. So here I'm going to say I need maybe 5 by 5 convolutions. And then afterwards, I need to specify my activation. So my activation in this case will be equals to relu activation, which is, again, as I mentioned, relu is used to improve the sparsity of the feature maps. And then I need to specify my input underscore shape. And my input shape in this case is, because it's a grayscale images, will be simply our 32 pixels by 32 pixels by 1. Looks great. And then what we could do afterwards is that we can add basically our average pooling layer. So we're going to say CNN dot add, and then I'm going to say take my layers dot average pooling 2D. So I'm going to say average pooling 2D. Okay, so now I added convolutions and then average pooling 2D. And then what I could do afterwards is that I could simply take all these feature maps and simply flatten them up. So I'm going to say CNN dot add, and I'm going to add layers dot flatten. So flatten will simply flatten it up, and then I'm pretty much ready right now to add my dense, fully connected artificial neural network. So I'm going to say CNN dot add, and then I'm going to say layers dot dense. So that will be my dense layer, and then I'm going to specify maybe I have 120, for example, neurons, and my activation function in this case would be relu as well. And then maybe I'll add an additional dense layer. So I'm going to say CNN dot add, and I'm going to specify my layers dot dense. And I'm going to say maybe I need 84 neurons, for example, and I need my activation to be equals to relu as well. Okay, looks great. And then what I need at the end, and that's very important, because here I'm classifying 43 different classes, I need the output layer to be consisting of 43 neurons, and that's an important part here. So I'm going to say CNN.add, and I'm going to say layers.dense as well, and that'll be the output. So I'm going to say my 43 neurons, and I'm going to say my activation, in this case, equals to softmax. Right, looks great. And then at the end, I need my CNN.summary, and that will give me a summary of my model. Looks great. So let's go ahead and actually run it. So press Shift Enter. I hope no error appears. Okay, looks great. So now the model ran, and now we basically built our model. As you guys can see here, you'll be able to actually see what you have built. So now I have convolution layer 2D, and there is 156 tunable parameters. And then there is average pooling 2D, and that would be the second step. And then we flatten them up. So now I have 1176, and then I have a dense layer, and here that consists of 141,000 neurons. I'm sorry, 141,000 tunable parameter. And then I have another dense layer of 84 neurons, and then I have my output, 43 neurons, and now I have 155,000 parameters to train. Okay, so that's basically how you build our convolutional neural network. And now it's time for a fun mini challenge, and that will be a little bit tough one. What I want you guys to do is to basically go here and add an additional convolutional layer, okay, that consists of 16 filters, and the size of the filters is 5 by 5. And I want you as well to add an additional average pooling, okay, so it looks pretty much the same as this one. Okay, and I want you to add afterwards a dropout layer. I didn't specify how to do dropout, and that will require you guys to do external research. So please go ahead and see how to implement a dropout. It's just a simple line of code. Do a little bit of quick Google search and try to add it here, and then run the network, and let's see what you guys are going to get afterwards. So please go ahead, pause the video, and I will see you guys after the.
Okay, so the first thing we need to do is I want to see this one. That the ChatGPT explain is for us. We log in. And we want to see this one also. See how Python function function machine learning. Pattern H-trend line. H-trend is the numpy array contain the set of training image. Okay. Divide each pixel value in the array by 3. It can be usual. Normalize pixel value between them. Okay. Calculate the pixel value in the array by 3. Calculate the pixel value along the top edge represent the color change of image. Cover each fresh frame blue image into a canvas. Calculation of the pixel value along the top axis. Visualize the sum should be take okay, 3 axis. So we should have the same number of dimension and input array. Okay, so I think we can understand this line. Code take the set of RGB image and convert them into vertical image by checking the sum of the value. Sum the value of each pixel. Okay. And then that's okay. Subject 1 to A for each pixel value in the array image. 0. This center the pixel value 0. Okay. From this one, and then when you subtract this one, take on. Okay. Subtract from each pixel value. Center pixel value. Okay, now we understand that. And then we do our next step. Okay, so normally first we copy the thing he's doing here.
It's time for a fun mini challenge, a dense layer, and here that consists of
okay, after we solve it, and then we have a combine train, a set train is the model performance. Congratulations. That's it. Okay, so we do it one first. CNN model. Convolutional neural network. Okay, and then C1 CNN. Yes. Yeah. Controlling six. And then we have five, okay, something like this. And then we have duration equal value. Then input shape equal vertical What? Okay.
Part here. So I'm going to say CNN.add, and I'm classifying 43 different classes. I need the output layer to be.
And then CNN is array to be okay. And we have something like this. CNN and layer okay. CNN is layer in control duration no CNN apps layer then control function no okay.
Consisting of 43 neurons, and that's an important part here. So I'm going to say CNN.add, and I'm going to say layers.dense as well, and that'll be the output. So I'm going to say my 43 neurons, and I'm going to say my activation, in this case, equals to softmax. Right, looks great. And then at the end, I need my CNN.summary, and that will give me a summary of my model. Looks great, so let's go ahead and actually run it. So press Shift Enter. I hope no error appears. Okay, looks great. So now the model ran, and now we basically built our model. As you guys can see here, you'll be able to actually see.
Okay. Then how to show convention short math summary. Okay, and then we write what we need one more M here. Then to refine convert to Boolean rather than dense. Okay, I don't understand. What the hell? Team Harry dense. Okay, I still don't understand. So, like, copy it to ChatGPT. Coordinate best. In Python, that define the convolutional neural network using Keras API within tensor graph and write down what is line doing. Import necessary category for real. Okay. This line natural is model at the control stack real. Okay. This line at corporational layer with 6 filter. Okay. Assign 6 filter by using resolution function This will input shape. Okay. Input shape. Okay. This layer will learn 6 sets of filter to convert the input image. This line adds an average pooling layer to reduce the partial dimension of output required layer. This line flattens the output required layer to the one-dimensional vector with ratio at the input of the dense layer. Okay, this line adds a fully connected dense layer with 120 neurons and the ReLU activation function. This line adds another connected and final dense layer with 43 neurons and a shock mask activation function. Together we output the probability distribution over the 43 nulls in the dataset. It's like print the summary of the CNN model of architecture industry. The output shape of it clear number of convolution model. Single convolution neuron by the average pooling layer, two full connected dense layer, and the final dense layer with a short mass activation function for classification. Okay. Somehow, yes, I understand.
The model ran, and now we basically built our model. As you guys can see here, you'll be able to actually see what you've built. So now I have convolution layer 2D, and there is 156 tunable parameters. And then there is average pooling 2D, and that would be the second tunable parameter. And then I have another for a fun mini challenge, and that would be a little bit tough one. What I want you guys to do is to basically go here and add an additional